Hello everyone, welcome to my channel. In this video we will talk about chapter 1 of database internals. This is pretty good book, and we'll cover some of the concepts from chapter 1. Okay, let's start. So, uh, so the first thing is how you categorize database. This chapter is mostly about introduction to database management systems. So there are, based on type of storage, there are two types. Okay, so first is memory based, which is also known as in memory, and another are disk based, which mostly store data on disk. Now let's go into detail about these two, right? So main memory database mostly store data in RAM, okay, hence they are faster, and disk based are slower because they store most of their data onto the disk. Not everything in main memory is stored in RAM, so some of the things where they want to, do a logging and a recovery, these things are still stored on disk. We'll see this recovery and logging and how they are useful in restoring the database later. Okay, and another thing is about the checkpoints. So let's say you have a RAM. Okay, there are some fields which are which database has in the memory. So what some databases do is, what they would do is they would keep on maintaining a log, okay, and keep sending these instructions which the database receives and also store in these logs. So these instructions can later be used to restore the entire database in case this thing crashes, because this is in memory. If power goes off, then the data is lost. So to make the data persistent, this is one of the strategies which can be used, that all the instructions which are coming to a main memory, you persist those instructions in append only logs. Usually these are append only logs. Okay, so but these logs can become huge. So to avoid that, there is another async process which few in memory database uses. They would say, okay, let me take a snapshot of database until here, and they will save that snapshot on the disk. Okay, let's say this snapshot is S1, and remove all these logs, because these logs are not required now, because we already have a snapshot of a data up till here. So this is a sync process which they do to manage data on the disk and to manage the logs so that they don't become huge. So this is also known as checkpointing. So this is some of the concepts which in-memory database use to persist the data. Okay, moving on. Disk-based database, we have already mentioned, they store on disk. Some of the things they also do in memory would be caching. So let's say the database is storing their data on disk, but to make it little faster, the query faster, they also use a memory in RAM for caching some of the things. So it's not entirely that main memory uses everything in RAM and nothing in disk. So, but majority of things they use in the main memory or on disk in case of disk databases. Okay, so let's go on. So this is obvious, main memory is faster than fetching from disk. So usually, I mean, disk is always slower. It is also because there is a head on for HDD to read. There is a seek latency. The head has to locate the data on this spinning disk, and the seek latency is introduced when the data is on hard disk, and then you locate the data, and then the page is read and brought to in memory, and then you can perform the operation. So that's why hard disk drives or disks are usually slower than RAM if data is stored in RAM. Also, next thing is memory management is easier in main memory, because in main memory you can use pointers, okay, to access the data. For disk, all that management you have to do yourself. For main memory, OS takes care of a lot of it, so that's why memory management becomes easier. So to summarize, memory management is easiest in memory. In memory, databases are faster, okay, but they are also volatile. Okay, so this is just an introduction for main memory and disk-based DBMS. Now let us look into databases based on type of queries. First we'll go over OLAP, which is, in the name itself there is analytical. So these are mostly used for analytics. Okay, so anything that is other than analytics, which is general query like give me salary of this person named John, okay, give me address, give me these details, so those are all OLTP. Okay, and the queries which are for analytics, let's say you have a set of salaries and you need average, okay, median of salaries, etc. So these are OLAP databases. Okay, and then there is combination of two, which are hybrid. That's just a simple introduction to these. Now let's go on to discuss DBMS architecture. So this screenshot is directly from the book, okay, but I've divided it into small chunks and we will go over these chunks now. So in case of browser and a web server, when you are making a request, okay, then browser is your client and web server is your server. And but in case of databases, there is a database server, okay, and then there is an app. So in this case the app becomes a client and the server that is hosting a database becomes data servers. So just a simple introduction. Cool. Now let's go on to the transport in the database. Okay, so we check this screenshot, right? So this is directly taken from these screenshots and adding the details. So it is responsible for doing a cluster communication, one. Second, a client communication, and input to this is just a query in some query language. Okay, so if there is a database which has, let's say, 3 clusters, I mean 3 nodes in one cluster, and then there is a client, so this transport module would communicate with these clusters and also with the client. And the output from this is the query itself. Okay, and then this query is passed to query processor. And now let's see what query processor does with the query. So query processes mainly parses the query. Okay, there is a parser written which parses your SQL query, whatever you write. Select star from whatever. Okay, and then there is a query optimizer. So query optimizer optimizes and produces an execution plan. Okay, it produces an execution plan based, I mean, there could be many execution plans, but this tries to optimize which would be the best. And that execution plan is passed to the execution engine. So now we have reached to the execution engine. So execution engine, you see there is a remote execution, right? So let's see what remote execution means. Let's say this is your execution engine. Let me call it EE. This is responsible for communicating with other nodes in a cluster, reading the data and writing. Okay, I mean, any query comes, it executes, it would execute on this node as well, this node as well, and this node as well in a cluster. And also replication, if there is, there is a replica which needs to be maintained, so that is also done by execution engine. And then the local execution is executed by storage engine, which is actually the, I would say, a heart, or you could say brain as well. I mean, very important part of a database management system. So storage engine itself has multiple managers. One is first is a transaction manager. So transaction manager, usually what it would do is, let's say you have multiple transactions, multiple things you are doing. You are, let's say, adding a money from one person and adding to one person and deleting. Let's say John pays me 10 rupees. So it has to deduct 10 rupees from John's account and add into my account. Okay, so transaction manager would make sure that both the things are executed or nothing is executed, so the data is not left in a inconsistent state. That's a responsibility of transaction manager. And lock manager, what it would do is, it helps in locking the database objects. It could be a row, it could be any field, things like that. And together transaction manager and lock manager are responsible for keeping data consistent. So lock keeps consistent when concurrency is involved. Okay, and this transaction manager sees that both the things are executed, all the things in a transaction are executed, or neither of them. So responsibility is to maintain consistent state. Okay, let's move on to other things in storage. One is access methods. This is mostly data organization, how actually the data is stored in the files. Okay, so they are usually stores like B tree, which we'll discuss in the next chapter, B trees, LSM, etc. This is data organization. This is the actual way how the data is stored in the files. Okay, and there's a buffer manager. So when the data is on the disk, right, so you need to fetch the pages into the cache and stuffs like that. So that is done by buffer manager. Caches data pages in memory. If you need again, you just read it from the buffer. Now let's go to the recovery manager. So in memory database case, right, we had looked into that there are logs which are maintained, right, when there is a data written on to the memory, the same instructions are sent to the log as well. So these logs help to recover data because these are set of instructions, and if you execute these instructions one by one, you will get the end state of the data. So recovery manager maintains the operation logs and responsible for the recovery. Yeah, it would be responsible for recovery because it maintains the operation logs. Now let us look into the drawbacks of main memory databases, right? So first is they are volatile. If you switch off the system, the data is lost. Okay, another is high cost. RAM is expensive, costlier than hard disk drives. But there are some new technologies coming up which are non-volatile memory technologies that might increase the adoption for main memory databases. Then they won't be volatile if you use them. Okay, now let's go on to how we can make in-memory database durable, because they are volatile and there are some hacks. I would not say hacks, but yeah, there are some ways you could make them durable. So first one we already had discussed. These are the write ahead logs. Now let me give it a little bit of detail here again. So let's say there are instruction 1. You get instruction 1 in the main memory, and then you get instruction 2, instruction 3. These are all the instructions based on the queries we are giving. Okay, so these same instructions are written to the logs, write ahead log. These same instructions are copied to the logs and stored on the disk. So if this guy crashes and we want our database back, we can read all the instructions that were written on the disk, and then we'll get the final state of database, which was exactly what we had. Okay, so this is one way. It won't be 100% same because there could be some instructions which are in flight, etc., which will be lost. But usually these databases do not respond that okay, yes, your data is committed, without making it persistent in the logs. Cool. That is use of write ahead logs on disk. Another is use backup copy logs to restore data, right? So we discussed earlier, similar to what we have write ahead logs, we also write these instructions to backup the data. So there is node 1, it writes the same instructions on disk, let's say D1, and this is on disk, this is on memory. If this is lost, we can recover data from the backup. So these are usually updated asynchronously. You could say there are snapshot also that can be used, which we discussed earlier, checkpoints right? So these snapshots can also be used to recover data. So at least up till that particular checkpoint, you will be able to recover everything. So that is another way. Yeah, and checkpointing we have already discussed before. Cool. Now moving on to the most important topic of this chapter, which is column versus row oriented databases. So basically column oriented stores data column wise, row oriented stores data row wise. Let's see in detail what I mean by that. Let's say this is one table, okay, and this is another table. So whenever we would fetch a data for this person named Curious, right, usually we try to get this information, right, for this person, like name and address. So it makes sense to save this entire row in the database. So this entire row is stored on the block, database block. Okay. So this makes it row oriented. And let's see another example. Let's say I have another query where I need average of a salary. If I go row by row, then I'll have to pick this first, then this, okay, and then I discard the names and get the salaries and find the average. A better way would be if this column itself is stored in the database block, right? 10,000, 20,000, 30,000. So this makes it column oriented. Okay. So that is basically a difference, but there is more to it, which we'll cover now, which is about the optimizations in column oriented databases. And this is from the book itself. If you can see, so these are how the data is stored, right? So symbol, date, price, and this is stored. One is row. So this symbol is stored completely. Okay. So this is column. This is row. Symbol, date, price, row wise. So that's how they are different. This is exactly what we discussed just now. Now optimizations. So optimization on column oriented is that the entire column is saved, right, together. First thing is the column will have a same data type. Let's say if it was a salary, so they all will be number. And if they are of same data type, you will get a better compression ratio. Okay, that is first advantage. Okay, and the second is there are vectorized CPU instructions that can process multiple data points with single CPU instructions, because this is the entire column which we can pick. So, and we can do a processing on an entire column. So we could use vectorized CPU instructions, which makes such things fast. And because of these things, right, like for example, the column oriented usually are used in OLAP analytics. We already discussed before, finding average, finding mean, mode. In those things you need to pick up the entire column and do some operation, or a part of a column and do some operation on that for the analytics. So that's why these are mostly OLAP. and another type where you want to get details of person named John, they will be OLTP. So that's what is discussed here. And which one to use mostly depends upon your access patterns. Okay, if your access pattern is more like ordinary query, then you use a row based. Otherwise, if it is analytics, you use column based. Okay, now let us look at data files and index files. So in databases there are two types of data files, right? So one is the data files, the first ones. Another are the index files. So in data files, as the name suggests, actual data is stored, and index files, there are indexes. So okay, we'll go what indexes are later. First, let's see why we are using data files and index files. So first thing is for access and update efficiency. Indexes mostly make access to data fast. Each table is usually a separate file. Indexes are used to avoid searching the entire table. So if you have an index, then index has kind of address of data you are looking for. So it will just go and try to locate in exactly that area or somewhere in the range of that area, and then you would get the data. So that's why they make the query faster. Data files store actual data, index files store record metadata to locate the records. We'll go into details, that's why I'm not covering here. More storage systems do not actually delete data. Okay, let's go over this. So let's say you have a data and you want to delete this record, this particular field record, right? So the storage systems, what would do is they will mark this data for deletion but not actually delete it, because delete is expensive operation. So then this would get deleted later by a garbage collection. It will pick up the page, whatever page it needs to read, will bring it into memory, delete what deletion is required, and write back the remaining. This is a background async process which is done to delete the data that is marked for deletion. Okay, this we covered. Let's see what different types of data files are. So the first type is heap organized. Okay, you can think of heap as a pile of clothes, okay, which you are taking for a laundry. So they are unorganized. Okay, they are unorganized, or you could say heap of clothes. That way you might find it easier to remember. That's how I remember. Heap of clothes are unorganized data, so they do not follow any definite pattern, and it is just stored in the file in unordered fashion. Okay, for such organization there is another additional index structure is required to locate the data. If this is unordered fashion, right, you would need another data structure index to locate the data faster. Okay, so that is heap organized. Hash organized is the key. Usually each row has a key, primary key, which we call it. This is also a primary index. So the hash of this key is used to locate the bucket of the data, and it can tell where the data is actually stored on the file. So that is hash organized. So, and the data within a bucket can be sorted order for quick lookup. So if the data is in sorted order, it's obvious that it would be easier to find it, right? So you could say something like binary search, which is log n for the search. Another is index organize. Index or organize is commonly known to everyone. So there is a data file, there is an index. So a index organize could be that index itself either stores the data also. If data is not much, the index itself can store the data, right? Sometimes data is stored as different file. In case of index holds key to uniquely allocate the data in a data, and sometimes it is the index itself has the data. If there is a different file that is used to store the data, then the index would have the key to that particular data. Okay, these are the data files: heap, hash, index. Now let us look at index files. Why do we use, okay, for quickly locating data, right? So there are different types, primary and secondary. Whenever you create in usually RDBMS, right, relational databases. So the primary key is usually a primary index, and you can have a secondary index if you want, right? You can have an index on other frequently queried columns. Okay, so that is primary and secondary indexes. Okay, and if key is ordered, okay, so if key is ordered, they are known as clustered. If it is not ordered, then non-clustered. So if key in the primary index is ordered, usually if that is the case, it is also primary index. In primary index, usually the keys are ordered, and in secondary, usually they are not. Okay, this is another quick definition. Now let us look at primary index as indirection. So there are two ways you can manage secondary indexes. One is that they directly point to the data. Another is they point to the primary index, and then primary index points to the data. Let's say you have a secondary index on email, okay, and I'm trying to search some email. Let's select star from this table where email is this. So what would actually happen here is that we would go to the B tree. That's how indexes can be stored. That is one of the way. We go to the B tree and find the location for this particular email in the data. We get that location and we fetch the entire record. Okay, so here we did just one B tree lookup. Okay, let's say the same case when the secondary index points to the primary index and the primary index points to data. In this case, what would happen is you will do a one lookup for secondary index email. That will give you a primary ID, primary key for a record. Then you will search that primary key in primary index. Then you will get some address. That is where the data is stored, right? Then you will fetch the data from actual data file. So in this case, you will have two lookups of B tree. Okay, so when you are reading a data, this is slower, this one is faster. But in the write heavy systems, okay, let's say you have 5 secondary indexes. Write heavy systems, when the data is moved, okay, let's say data gets moved, then you will have to update five secondary indexes. Okay, so write becomes slower in the first case, but write will be faster in the second case because you don't have to move change the secondary indexes. Only the primary index updation should be fine in case of data is moved. Now let us take a look at three quick definitions which are used in databases. Okay, so the first is buffering. Buffering is how much a database needs to keep in a buffer before writing to the disk. So let's say you have this in-memory database, right? And you have some buffer. You're writing instructions to buffer, and when this is equivalent to the size of the page, then you write to the disk. So because you can only write the entire page, okay, so that's why it is always desirable to wait until you have the enough data equivalent to page size to write to the disk. So that is buffering. It depends from database to database how they manage this. Okay, another is immutability, and in this case, let's say you have a data stored on the file. Usually that's not the case. That would be some database organization, but in immutable structures, datas are only append only, just like logs. You do not go and change the existing data, but in mutable structures you go and modify the existing data. Okay, another is ordering. If data records are stored in key order, ordering can help with getting range of records faster. We already have seen if there is a key order, then it is faster to fetch the data, right? And if it is not ordered, read is slow. Okay, but if it is not ordered, it is append only, and the writes are faster because you don't have to seek and maintain the order while writing. You can just append at the end, so the writes are faster, but read would be slower. So that's a trade-off in case of ordering. That's all from chapter 1 of this book. Thank you.